Okay, folks, we're going to get started at this point. I said I'd start at a quarter after 1, so it's about that time. Good afternoon. I am going to quickly start with a little tutorial on using an equation editor. Since more and more of our work is being done electronically, if you can get used to an equation editor, it does actually make typing equations a lot easier. And it's definitely nicer to mark because it's a little bit cleaner. Now, I was going to show you Equatio, and I didn't test it before trying to show the previous class, and for some reason Equatio wasn't working. I'm still going to pull it up and show you some of the features of Equatio, but I'm going to actually start just by showing you the regular Google Docs equation editor quickly here. So to be able to input an equation, first thing you want to know is that the equation is going to be inputted wherever your cursor is. If I go to insert and right here equation, what it does is it puts this tiny little equation bar along the top of the screen here. Now, so let's say I wanted to type an equation in. Now you'll notice, I don't know if you can see that, but there's a slight little box that opened up where my cursor is. That's because it's inside the formula box. Formulas are actually typeset as images in a document, so you have to type out or into the box if you want to get the equation stuff going. So let's say, for instance, I wanted to do a square root. So if I look over here and click on the operations thing, there are some square root types. There's the regular square root, and then there's the n root type. And I know it's very small to see on your screen. I'm not sure if you can make it out, but as soon as I click on it, you're going to see that it gives me the square root symbol, and it's in the position to put the index. So if I put a 3 there, and then I put a 6, and let's say I'm finished, and I click outside. So now that is an equation right in my document. Okay, you can always just click on it to edit it, or you can click outside to leave it. What's nice about these buttons here is, now to do another equation, I'd have to go insert again, go back to equation, and it opens that box again. Now I have access to these little buttons. Let's say I want to do a fraction. Well, as soon as I press the fraction, I could do something like 3x minus, 5. So I can't see my keyboard, so I might mess up a little bit here. Let me pull my keyboard out. Close the bracket. Oh, I wanted to go underneath that fraction, so I'm just going to click underneath the fraction. Get my cursor there, and I could do 2x or 3x again. The power button on a keyboard is Shift 6. So if I wanted to put a power, I would put a power there. And now I have that nice little fraction formatted there. So the only issue with the Google Docs equation editor is I find that when you're doing fractions, it makes it small like this. And as far as I know, there's no way of making it bigger. I could be wrong on that, but there's no way of making it bigger. So let me just show you MathType. Now the problem with MathType right now is it wasn't inserting the equations, but I just want to show you some of the functions of MathType. Not MathType, sorry. Somebody threw me off by writing MathType in the chat. Equatio is the one I want to talk about. So Equatio, once you've installed it, and I've put a video up on how to install it on the Google Classroom, there's a little blue button at the top here. If you click on that, it brings up the Equatio toolbar. So if I wanted to type an equation, I would just type on the equation editor here, and I could start typing my equation right here. So let's say I do 3x minus 5, close the bracket, divided by 3x to the power of 3 like I did, or whatever power I want, okay? Okay, somebody's suggesting in chat that you can probably just select the equation and make the font size bigger. That'd be interesting. I'd like to try that, but not right now. I'll see in a second here. So this is the formatting in in Equatio. I made the mistake again. In Equatio, and I mean, I'm just going to delete this actually because I don't even need to. I don't think actually. Let me leave it there. I wanted to mention, how do you get a division symbol on a keyboard? The division symbol is just the front slash button, okay? And Shift 6 is the exponent button. But if you click on more here, and you click on symbols, that's where all of Equasio's math symbols are. And there are quite a few of them, okay? So, and there are things like units in here, there are Greek letters, there's all kinds of things. Degrees Celsius is there, okay? So you can get all of these in this list. And I mean, here's the root one. So if I wanted to input a root, I would just click on that, and then you could change the index of the root by cursoring up to it and going into the radicand and changing it to whatever you wanted it to be, okay? If you wanted a superscript or a subscript for like a power or something, those buttons are in here as well. So the superscript is right here, but Shift 6 is an easy keyboard shortcut to remember. It's the caret or the hat symbol, okay? But you could click on that and it gives you the X, so I'd have to actually erase the first X there. Okay. So the issue is, and this is what messed up, and I don't know why it's messing up, to get it into your document, you have to press on Insert Math. Now, when I click on Insert Math, my cursor stops flashing. Usually what happens is a box shows up and the image is put there, but for some reason it's not working. And I'm not sure why. I don't know. It even says pasting the math here, but nothing happens. So there's something wrong with my version of Equasio, and maybe it's Equasio in general today. It should be putting the image right there. And what's nice about that image is it's formatable. You can make it bigger or smaller just by grabbing the box and making it bigger or smaller. So that's the nice thing about Equasio. Another nice thing about Equasio, now, I'm wondering if one of the problems I'm having today, folks, is because I'm actually signed in as two different accounts. I have my own personal account and I have my RS Cloud account. I've fixed Equasio in the past by signing into my RS Cloud account for Chrome, not just for Google, okay, to get the premium version. Right now, I don't have the premium version. I have the free version, which you see flashing in yellow down here. But I believe all Rainbow students, if you sign in as your Google, in Chrome as your RS Cloud account, that you should have the premium version of Equasio. Now, the reason I'm mentioning that is because of this functionality here. Handwriting recognition is pretty cool. Let me delete this formula here that I had typed in. And now you'll notice, because it's the free version, that I only have 2 free inserts. If you have the premium version, you can do as many as you want. But what's nice about the handwriting thing is, let's say you're working on your phone and you wanted to input an equation. If you use your finger, I'm using my mouse, so it won't be very nice. I don't even know if it'll recognize that. Yeah, it did. See? Over here, it changed it to 3x, so it actually recognized my handwriting. I could put a bracket around there, put a power of 2, and it should, within seconds, update that. Okay? So that's pretty cool, right? And then if it worked, you would just type insert or click on Insert Math, and it's supposed to insert it in here. I don't know why it's not working right now. Okay. The other one that I wanted to show you is the speech input. So I'm going to delete this. Now, as soon as I press the record button, it's going to start recording my voice and transforming my words into an equation. Now, you've got to remember to press pause when you're not speaking math words, okay? But it's pretty good. Now, when you usually touch this the first time or click on it the first time, if you're on a PC, it's going to ask you to enable your microphone for Equasio, okay? I already did that, so it shouldn't do it again, I don't think. Bracket 5x minus 4, close bracket, over 7x squared. Now, when I said over, I maybe would have had to wait there for a second, because I don't know why it didn't write it over 7x squared, and something messed up. But it's still pretty accurate, okay? And you could always just click on here and edit the equation if you wanted to. Okay, so there's ways of doing that, but there's all kinds of commands that you can do, and I don't know them all, but if you go to the Equasio website, they actually have a list of all the commands that you can do with speech. So for instance, let me try this again. cube root of 8x cubed. So that's pretty good for a speech-to-text software, okay? And then, like I said, if it worked, I could just click on Insert Math, and for some reason it's not working, but if it worked, it would put it in here, okay? So supposedly if I change the font size, let's try this. I don't think this works. Yeah, so changing the font size in here did not work, okay? So I don't know how to make the regular ones bigger, but the Equatio ones usually can be made bigger. There are other equation editors. MathType was mentioned. I think MathType you have to pay for, though. But there are some free ones that you can find as well. But it does make typing math quite easy. If you're in a science class and you ever have to do like a chemistry equation, there are some, I don't know if they're here. I think there are. So let me insert another equation here. I hope you don't mind me taking time to explain this, but I think it will be useful for you. You know, in university, for instance, they're going to probably ask you to type everything. So let's put in an equation, and if I do like this one here, okay, I'm not doing a proper chemical equation here because carbon is not 3,4, but if you were in chemistry, you could put the proper chemical element, the mass of the element, and the number of protons there, the way it's supposed to be done. Now, sometimes they ask you to do it behind the letters. I don't see that particular one there, but they have integration. They have all kinds of different symbols, okay? So, very useful tool for anybody. Okay, somebody's saying there's an option as you're writing the equation where you can pick the font size. Okay, I don't know where that is. I'm not sure where that is. So, yeah, integrals are there. Okay, but anyway, it does make, like I said, your life a little bit easier. So let's go to, I didn't want to just delete that. Go to the smartboard here. I closed the window by accident. Okay, so let's start today's lesson then. Today's lesson, as I mentioned in the classroom, was basically going to be me going over a bunch of examples in your homework, okay? And this is actually going back to a few days ago. So one thing about your homework, folks, I'm going to be returning your entry cards and your ISUs. Just like class rules, you're allowed to resubmit those for extra marks. So if I put a comment on them saying that you had to or could fix something, please fix it and just click on the resubmit or submit button again. And I will see that it's been resubmitted and I will remark it and give you half of the difference to 100%. So that goes for your entry card and your ISU, all right? I have returned a few of them already, but I only returned some of them that were that had mistakes in them. Anybody who got 100% and handed it in did not get it returned yet. Now I'm still doing that for both classes, so I may not have gotten to everyone in both classes yet, but I think I got quite a few of them done last night. So please resubmit them with corrections. You will get extra marks for that. All right. As for a midterm mark, I know that we're about 3 days away from midterm at this point, the official midterm date for like the middle of the semester. I do not want to send home a midterm report card until I'm done marking the ISU and the entry cards. So don't expect them until that's finished. It shouldn't be too much, too many more days for me to get that done. But if I don't get them in soon enough, you will be getting 0 on those, and I will be sending those reports home that way until you do submit it. So keep that in mind. Okay, I'm not going to make everybody else wait just because there's 1 or 2 students that haven't submitted it yet. So get those in ASAP, please. Now, for what's on the screen right now, sorry, I just need a drink of water here. So this is number 14 from a few days ago, and the A and B questions are very, very similar to the one that were on your entry cards, the fourth question. So I'd kind of like to go over these with you, at least one of them, just so that you can see and we can discuss why these are a little bit trickier. Well, the reason they're trickier is because of the addition and subtraction. Okay, what I saw a lot of students doing is trying to flip negative exponents in this, and you can't do that here because of the addition and the subtraction. Additions and subtractions are evil, okay? They always make things more difficult. So the only thing you could do, even though you couldn't flip them like this way, 6 to the negative 1 can be written as a fraction. It just has to be written as a fraction in the numerator. And I'm going to drop the 1s here because we don't need them anymore. Okay, so they just become fractions in the numerator and the denominator separately. And what I'm kind of hoping you'll see from now on is that this is the addition of something with a fraction. Now look at this one. Can you see that there's two fractions up here? It's 1 over 5 to the 4 and 1 over 5 to the 6. So you're just adding and or subtracting fractions. And in this case with whole numbers, but it's still the same rule. We need a common denominator. So we're going to multiply the top and the bottom by 6. There's a 1 hiding under that 6. There's a 1 hiding under this 6. That's the way this one has to be done. Okay, and the one on your entry card, same thing. So we've got 6 over 6 plus 1 over 6. And 6 over 6 minus 1 over 6. Now, some of you may have been able to do this a little bit quicker, but I just want to show all the steps here. 6 plus 1 is 7 over 6. 6 minus 1 is 5 over 6. Now, I always had trouble with these when I was in high school, and it took a university professor by the name of Andre Roberge to help me figure out how to write this in a way that my brain could comprehend. I don't know what would happen. I think it was because you saw how I extended that middle line there. If I went back to the way I wrote it originally, like this, my brain would start to think like, is this a fraction? And I don't know why. I just couldn't get it out of my head. So, and I couldn't put it in my head as to how to do it correctly. So what he said to do is to write any kind of division of fractions like this. And then he said you flip and multiply the second fraction. For some reason that clarified it for me completely. Okay? So we get 7 over 6 times 6 over 5. So we're flipping and multiplying the second fraction. And I showed you a few days ago, I don't remember when, that anytime you have, and notice that we no longer have additions and subtractions, by the way. We're down to just a division and a multiplication now. Okay? So now things work more like we're used to and the way they should. The 6 and the 6 here are actually one on top of the other. So you can actually cross those off. 6 divided by 6 is 1. So our final answer is 7 over 5. Without having to multiply top times top and bottom times bottom and going through that rigmarole and then having to find a simplified fraction, simplifying it on the way makes things a lot easier. Okay, so those of you that were struggling with the fourth question of the entry card, that question and B is actually a little bit more complicated, but not by much. It's just that the numbers are bigger. Should fix the problem for your entry card. Now for number C, or for letter C, sorry, I'm going to just add a letter page here, sorry. I want to do C with you, okay? So it's 2 to the negative n, 2 to the n, and 2 to the 1 plus n. So let me see if I can remember that. 2 to the negative n, 2 to the n, 2 to the 1 plus n. I had a student ask me a question about this one, and I just want to go over it so that we can talk about the puzzle nature of this question and the interesting setup here. So the first thing I would do is, first of all, notice that it's a minus sign, so things are going to be icky. all right? But then I would take this to the negative n and I would write it as a positive power by flipping it, okay? And the reason I would do that is because I would notice, oh, there's a 2 to the n in the bracket. That means when I distribute the 1 over 2 to the n times the 2 to the n, that there's something interesting going to happen between those two, okay? But it'd be really nice if there was a 2 to the n hiding in the second one too, because I could do the same thing with the second term. But there is a 2 to the n hiding in the second one. Can you see how this came from something else? 2 to the 1 plus n came from what? Well, what would give an addition of two exponents? It would be a multiplication of two bases. So there is a 2 to the n hiding in that term. So there's a couple of things we can do now. I'm just going to drop this 1 here because we don't need it anymore. There's a couple of things we could do here. We could either multiply the 1 over 2n in, distribute it in, or the 2 to the n can now be factored out, which is the way I would actually prefer to do this. And I'm doing it slightly a longer way, but I want you to see all the steps. So I'm going to factor out this 2 to the n and this 2 to the n out in front here. Well, what does that leave me inside the bracket? What happens when I factor 2 to the n out of 2 to the n? Well, 2 to the n times what would give 2 to the n? It'd be a 1. Here, the only thing that'd be left is 2 because I factored out that 2 to the n. And what's cool about doing that is 2 to the n divided by 2 to the n now cancel out in front. And you're allowed to do that now because everything is now multiplying. Right? The 1 over 2 to the n is multiplying the 2 to the n, so it's top times top, bottom times bottom, but 2 to the n divided by 2 to the n is just 1. So I'm not even going to write the 1. You're left with 1 minus 2, which is negative 1. So these were challenging. This one's a lot more challenging than the one on the entry card, but these were challenging questions that I had left you with, I think it was last week, in fact. If you take a look at D here, what are the special things that could happen with D? What does 3 to the 2 times x mean? What happens when you multiply a 3 times that? What does a 3 minus a 3 to the minus 2x mean? What happens when it moves up? What's going to happen inside that bracket? Okay, so there's a lot of things to discuss here. The main one is what happens inside the bracket, because if you can see what happens when that 3 to the negative 2x goes up to the top, this answer is pretty easy from then. Okay, but I'd like you to think about it. I don't want to just give away all the answers. Before I move on, just to repeat, these two questions, A and B, very, very similar to your entry card. So if you were struggling with your entry card questions, me doing A here should have helped quite a bit. And if you're still not sure, try B and see if you get the correct answer in the back of the book, and then go try the entry card. Yeah, somebody just gave the answer for D. I'm not going to explain how. Excuse me. Okay, so let's move on to our lesson from yesterday, where we were looking at things in fractional exponents, which we call rational exponents, and radical form, which is square roots, or types of roots, not just square roots. So let's talk about the word radical. Okay, this does not mean surfer dude radical. Okay, it's another word for roots, and I don't know if you're like me when it comes to trying to remember things, but these two words always mess me up in school. I'm not sure if it's because I switched from French to English at some point, but radical and rational are too similar to my brain, and it took me quite a while to be able to separate the two. Okay, radical means type of root. Rational means fraction. So you'll often see in this section write in radical form or write in rational exponent form. Okay, so you need to know the difference between those two words because they will use them to represent those two different things. Okay, So maybe it's just me that has that issue, but try to keep them separate. So this is just take all of these and write them as roots. Okay, well, let's just look at a few of them together. Let's look at B. By the way, these are the questions right out of your textbook. You'll be getting some in homework today. I'm going to do a few of them with you right now, okay, just to show you what kind of questions you're going to be encountering. So 37 to the 1/2. Well, what did we see in yesterday's video? Well, any rational exponent can be written as a radical. And the type of radical, the index of the radical, is the denominator of the fraction. Now, normally, when we're doing a square root, we don't write the index because it's right in the word square root. But it is a 2 in here, not a 1. I have seen students mistakenly think it's a 1 that goes in there. Okay, so that doesn't make any sense. It has to be a 2 if it's a square root. If we look at E, how is E different than B? Well, E has a number in the numerator that isn't a 1. So where does that number go? Well, from the video yesterday, the type of root is the denominator. The radicand is the base of the exponent. We call whatever is underneath the radical a radicand. Okay? And the power, the numerator, can either be written in one of two ways. It can be written as the power outside of the bracket, which is the way I prefer, or it can be written inside of the radical next to the base, radicand. Those are the two easiest examples, right? You need to know at least those two to be able to just understand how these work in general. Let's look at I. I is x to the negative 3 over 7. Well, what's happening with that negative? Well, now what we're doing is we're mixing two exponent laws. We're mixing the rational exponent and the negative exponent. So what does a negative exponent do? Well, a negative exponent sends the base to the, I want to say, opposite side of where it is in the fraction. So if it's in the numerator, it goes down to the denominator, and vice versa if it's in the denominator. So this x is in the numerator. So it's moving to the denominator, and the power becomes positive. So that's the first thing we would do. The second thing we would do is turn it into the radical version. So the type of root is the denominator of the fraction. And the way I like to write it is with the power on the outside. You could also write the 3 right next to the x here, but I'm always going to choose to do it this way if I'm given the choice. All right. Are there any questions so far? I didn't get many questions in the previous lesson either. Of course, if you ever do have questions and you don't want to ask them in chat, please email me separately, okay? I want to look at K and L. K and L is an important example to look at. And this harkens back to our discussion on when do you need a negative base to be in a bracket, and when it's not in a bracket, how is that different? This is a very similar discussion, okay? Clearly, for this one, the radicand is going to be the full 3x because the whole 3x is being affected by the 1/2. But in this scenario, for L, because there's no bracket around the base, 3x, there is a multiplication between the 3 and the x. And BEDMAS says we have to do exponents before we do multiplications. So I was kind of trying to mess you up by putting that 1/2 a little bit further away from the x there. The 1/2 is right next to the x. It is not affecting the 3. This is what that one would look like. Okay? So if, I'm just going to fix that 1/2, it looks terrible. If you have a separation with no bracket, even one that you can't technically see, I mean, if I wrote that 3 right next to the x there, that could be very misleading. you have to know that they are not technically connected within that 1/2 power. Okay? Only the x is being affected by the 1/2. The 3 is on the outside and therefore multiplies the answer of the radical there. Okay, let's move on. So here's question 2. Now question 2 could have been written using rational exponents. I have seen that in certain textbooks, okay? That would be helping you to understand that you're supposed to use fractional exponents when you do this. But there's the word rational, that's where it would show up. So this is the exact opposite of what question number 1 was. So let's look at C. Okay. Well, my radicand is -11. What is my power going to be? Well, the index to the root is 3. That is my denominator. I don't have an outer power, so that's the way I would write that. Now, one thing to be careful of. What if somebody wrote it like this? I'd like to tell you to not do that. Okay? You should not write a negative base without a bracket ever if you are given the choice. Okay? Now, technically speaking, and you can correct me if I'm wrong in chat, well, wouldn't the answer be negative anyway? Aren't these both going to give me the same answer, whether I do the cube root of 11 negative or the -11 cube root? In this case, it actually does work, where both of them give the same answer. But I think that's just a coincidence. Okay, I can't think of an example where it wouldn't work right now, but it's just bad form. It's not the proper format. Okay, the full -11 is under the root here. You really should have a bracket. Yes, but a square root. Oh, correct. You're right. If it was a square root, it wouldn't work because the square root of a negative number doesn't work. But you can square root You can square root 11 and then make the answer negative. Correct. So as long as your denominator is an odd number, both of these will give you the same answer. But it's a bad habit to start. Okay, I would suggest that you don't do that. All right. What about D? Now the textbook interchangeably, wow, I can't say the word. Interchangeably, is that the word? Uses either the version that I like, which is like F, or the other version which some books use, which is D, okay, to get you used to both versions. So this is just a scenario where, well, what's your index of your radical? Your index is 5. It goes on the denominator. But there is a power beside the A. That is the numerator of the fraction. Okay. Let's take a look at G. So in G we have 1 over root x. Now this is going to bring up a little bit of a discussion about what is the proper format to put an answer in that I may not have the answer for. The first thing we would do, we're writing it as a 1/2 power because a square root, this is a 2 hiding inside the index here. So that's 1 over x to the 1/2. Okay. Roots and bases are bad, but negative exponents are, in my opinion, worse. Yeah, so the textbook actually writes this as x to the -1/2. Okay. But I told you the other day that you shouldn't have a negative exponent in your final answer. So we're going to learn about rationalizing, which is something that was just mentioned in chat, at another time. We're not going to do that today. But there is a way to satisfy both of those cases so you don't have a root on the bottom and you don't have a negative exponent to your final answer. But if you look in the back of the book, they actually do use the negative exponent. Okay? And I feel like that should be enough help for this question for you to be able to do the rest. Some of them are going to leave as a challenge, like J, K, and L. They're not that challenging, okay? But I feel like that's enough for you to be able to do most of these questions. If there are any questions about anything, just throw them up in chat, or like I said, you can email me. I am going to switch slides though at this point. What does the word evaluate mean? Evaluate means get right to the final answer. If you need a calculator, type it into your calculator. Okay. Now, well, solving is different. Solving means finding the value of x. There's no x's in here, so it's not technically the same thing. We do use those two words interchangeably, unfortunately, sometimes. Okay, so it might be our teacher's fault that you think it means the same thing. But solving usually means isolate x. Evaluate means find the answer as a number, as a final number. Okay. Now, the first thing I want you to notice, and we'll discuss this first, is I asked you to kind of get used to, some of your cube values, your square values for sure, okay? Even some of your fourth values, like 2 to the 4, you should be able to pretty quickly figure out what that answer is. And that's all we're doing here, right? Like if we look at, let's look at B. I'm hoping at this point that you can all start to recognize this as being the cube root of 125 pretty quickly. And the cube root of 125 is that one right there, right? So the answer is 5. Can you see that for A, the answer would be 2 because it's the square root of 4. Now for 16 to the negative 1/4, how quickly can you flip that upside down in your head and do the fourth root of 16? So the fourth root of 16 is 2, so that becomes 1/2. It isn't a negative 2. When we flipped it upside down, the power became positive 1/4, right? That's what happens when you flip it upside down, so it would be just positive 1/2. Can you see for D, without even doing it on paper, that you'd be doing the fifth root of negative 32? So the fifth root of negative 32, the answer here is just negative 2. Can you see for E that this is just 25 to the 1/2, which is just the square root of 25? So you can write them out, all right? There's nothing wrong with that. But if you can start to see the answer before you write it out, it's just going to, help you comfortably and confidently get to that final answer. Like how quickly can you see that this one's a negative 1/3 for F? That means it's going to flip. This is going to go down to the denominator, so it's going to be 1 over negative 27 cube rooted. Can you cube root a negative 27? So it's 1 over negative 3. And if you couldn't follow me doing that, you may have to do this one on paper yourself in homework to make sure you're able to do it. By the way, looking at these two, if the fifth root of 32 or negative 32 is negative 2, the sixth root of 64 is positive 2. Okay, so there starts to be patterns there that you can see to help you figure things out a little bit. Okay, let's keep going. This is number 5. Now, number 5 was in 2 different columns in the textbook, so I had to split it up like this. Let's look at a few of these together. I'm not going to do them all. Let's look at D. Now, notice they're saying evaluate again in the real number system. So that means real number system means no complex answers. Okay. Now we know how to work with complex numbers, more or less. We've kind of started to look at that, so you could potentially find the answer anyway. Let's look at m for an example. Okay, but let's look at this one first. So 3 to the 1/2 times 3 to the 1/2. Now my biggest fear is that somebody's going to say that the answer is 9 to the power of something. Okay? Big mistake, done all the time. You're combining two bases. The bases do not change when you're multiplying or dividing. What's the rule? Well, we're multiplying two bases that have powers. What do we do with the exponents? Chat. That's right. What happens when you add 1/2 to 1/2? One half plus 1/2 is 2 halves, which is simply 1. Right? So that can happen when you're adding fractions. You could end up with whole numbers depending on what the fractions are. So you technically don't even need a calculator to do this one. The answer is just 3. Take a look at f up here. What's the rule when you have a power of power? Powers of powers multiply, right? So you'd have 5 times 0.4. What's 5 times 0.4? Well, what's 5 times 4? 5 times 4 is 20. So what's 5 times 0.4? Okay? So some of these can be pretty easy if you remember your laws and you know how to add fractions and you know how to multiply fractions. Divide as well. Look at h. Now h is a little bit more complicated, so I'm going to write that one out. If you don't mind, I'm going to write it like this. I don't like writing divisions with the old-fashioned division symbol. Okay? So we've got a problem here. Yeah, I can do n. Just remind me if I forget. Okay? But I'm going to do h first. So 4 to the 3 halves divided by 16 to the 1/4, you can't combine bases that aren't the same. But in our exponential unit, we kind of can use techniques from that unit to help us out here. Is there a way to write 16 as a base of 4? I'm going to write it out the long way here so you can see what I'm doing. So I took 16 and I turned it into 4 to the 2. Well, here we got another power of a power, right? So we've got 4 to the 3 halves at the top divided by 4 to the what? Well, what's 2 times 1/4? Well, it's top times top, bottom times bottom, which is 2/4, but what's 2/4? It's 1/2. And now off to the side, so I don't have to write it really small, I have to do what with those two powers? What's the rule where the quotient rule comes into play? We just subtract those two powers. What's 3 halves minus 1/2? 2 halves, which is 1 again. So my final answer is 4 to the 1, which is just 1. Which is just 4. Sorry. Which is just 4. Right? So my power becomes 1. 4 to the 1 is just 4. So that's some... these are interesting little math puzzles. I hope you find they're interesting. Just to play around with stuff and try to get, specific answers. So somebody asked me to do n. Oops, sorry. Let me add a page here. So it's 0.027, 0.25. My memory is horrible. Negative 2/3 and negative 1/2. Okay. So here's the first thing I would do. And this is a bit of a shortcut. I may have a sneeze coming. I might have to mute the mic in a second. So what I'm about to show you is a bit of a shortcut. We could write both of these as 1 over 0.027 to the power of 2/3 divided by 1 over 0.25 to the power of 1/2, like to get rid of the two negative exponents. Or where is that negative power at the top going to bring the 0.027? And where is the negative power at the bottom going to bring the 0.25? Doesn't the 0.027 just want to slide down to the bottom and become a positive power? And doesn't the 0.25 just want to slide up to the top and become a positive power? Now, there's no way that I'm going to be able to turn 0.027 into a base of 0.25 or vice versa. Okay, so this is not what this question is asking us to do. This question is actually asking us to do what is the power of 1/2 of 0.25. Well, isn't that just the square root of 0.25? Isn't the bottom one just the cube root of 0.027 all to the power of 2? And the reason I wrote it that way is because can you see that this is a square rootable scenario? What is 0.25 to the 1/2? Well, it's like square rooting 25, right? Now I believe the answer is 0.05. I always mess this up. I think there's a 0.05 in a case like this because, yeah, I don't think it's 0.5. Because 0.5 times 0.5 is a half times a half, which is a quarter. Oh, it is. I'm an idiot. Sorry about that. Did I forget a 0? I see, this is what I'm saying. I always mess this up too. Is 0.5 correct or is 0.05 correct? What two numbers multiply together to give 0.25? Because I think it's a half times a half. Because I was doing it wrong and it ended up with the right answer. It is 0.5. Yes. Okay. So I always mess it up too. I always think there's supposed to be an extra 0 there. So what is the cube root of 0.027 then? The cube root of 27 is 3. So again, I'm going to mess this up, folks. How many zeros do I have here? Is it 0.03? Is that right? Squared? So the bottom is 0.09. So don't trust me here. I'm having trouble with this decimal. Okay, is it 0.3 or 0.03? There is an extra 0 in this case. I think it's 0.03 this time. Correct me if I'm wrong. It's 0.3? Oh, gosh. Okay. I'm going to trust you. Okay, thank you. Because I don't know. This is something that's always messed me up. I'm not sure why. You know what? I just thought of a way that I could fix that problem for myself, though. Oh, this might help some of you, too. If some of you are struggling the same way I am, what if we wrote 27? You can write 0.027 as 27 over 1,000. Right? Yeah, if you think of this as a fraction, it's 27 over 1,000. You can do the cube root of this. That's 3 over 10, which is 0.3. Woo! I've just impressed myself. Sorry. Yeah, that'll help me figure that out. I just learned something. I'm 47. Okay. Thank you for indulging me there. Yeah. So this will be 0.5 divided by... Okay, now what's 0.3 squared? So I could use the same trick as I just used over here. What's 0.3 squared? 0.3 squared is 3/10 times 3/10. That's 9 over 100, which is 0.09. That's going to help me figure this part out without having a calculator. Okay, but obviously you can use a calculator, so I'm going to leave this one on the board because on the smart board because it's actually a trick that can help a few people out to figure that out. All right, we're almost done. So I did end. Did anybody want me to do any others? I feel like that's enough, though I don't want to give you too much help. Yeah, I don't care what you say. I'm not helping you anymore. You can figure out the rest on your own. And if you need more help, let me know. Okay? Question 6. So question 6 has some of these roots inside of roots scenarios. I'd kind of like to look at another one of those with you just to make sure that that's fairly clear. 20 questions inside a question, yeah. When you start breaking up these questions, you can find some really interesting little things inside. So let's do D. Square root of the cube root of 8x to the power of 7. So I use my idea of oysters and pearls. Okay, my pearl is 8x to the 7. And I have my first oyster around that. And it's a power of what if it's a root, a cube root? Well, it's a power of 1/3. And then that oyster has been eaten by another oyster. And that oyster has a power of 1/2 because it's a square root. So let's just deal with these two powers. Okay, so that's a power of a power. Powers of powers multiply each other. That gives 1/6. Sorry, my 1 looks like a 7. Let me fix that. Top times top, bottom times bottom. Now, we could potentially leave it like that. But you can also bring that power in. Doesn't really help us much though, because the 1/6 power of 8 is not a nice number. Okay, and what the question asked us to do, if we go back up, is write an equivalent expression using exponents. Well, have we not done that? Okay, so we could go to this extreme. I don't know what they did in the back of the book, but I would suggest that this answer is okay. All right. This answer is just fully expanded. I don't know. But I would suggest that either of these is okay because of the question just saying state as a positive exponent. Okay. So that should be enough. I mean, the rest of these are not very difficult besides the root inside roots questions. So I'm going to leave those up to you to investigate. Okay. Let's move on to the last one. So this is a thinking inquiry question that was in the one of the last questions of the unit in the book. And not the unit, sorry, the section in the book. I found it interesting that they threw this question in with the exponents stuff, but let's read through it and see what it says. So the diagrams show two squares with whole number areas that can be made on a 4-pin by 4-pin geoboard. Now, please, chat, can you withhold your answers for just a couple of minutes? Because I'd like everybody to get a good chance to think about this before they have to read any of the answers, okay? So what is a geoboard? Geoboards are these little plastic things with pins, and they used to put elastics around them to form shapes. I don't know if you use those in elementary school or not. They've kind of been falling through by the wayside throughout the last few years because technology has made it so much easier to just do things electronically, but some teachers may still use them. If the shortest distance between two pins is 1 unit. This is a math contest type question here. What is the area of each square? So let's look at the first square. Again, please don't give the answer away for the second one, but start thinking about the second one. But the first one is really easy because if the distance between one pin and one pin is 1, then we know that each side is 2 in length. The area for a square is side squared or length squared. I like to use length squared because length times width, length times length. Okay? So that's just 4. And what's interesting is you can see that just by drawing a line separating that and that. There's 4 as your area. Okay? But for the second square, yeah, talking about math contest type, this would be an easy math contest type. This is not difficult, but it might be hard if you're not looking at it the right way. Okay? There is no way of finding this length just by measuring it out. All right? Without giving the numerical answer away, what technique are we going to need to use to find the answer for the second square, chat? What mathematical technique? No numbers. Can you see how we're going to use the Pythagorean theorem to solve this question? Can you see that there is a right angle triangle bordering that side? And now you could draw it inside, you could draw it over here. There's like a lot of right angle triangles hiding in here, okay? And if we draw that right angle triangle, we know that this side length is 1 and this side length is 2. You can now find the hypotenuse length because hypotenuse is equal to hypotenuse squared is equal to a squared plus b squared. I know a lot of you use c. I don't like using c. H is hypotenuse to me, okay? So the hypotenuse is equal to the square root of a squared plus b squared. So that's just 5, sorry, give me a little answer away. That's just 2 squared plus 1 squared. 2 squared is 4, 1 squared is 1. It's the square root of 5. So the hypotenuse here has a length of 5. And now the area is equal to the root 5 squared, which is just 5. By the way, there's a lot happening in this question too. The root 5 squared is the inverse function of a function scenario, right? Squaring a root is an inverse function of a function. Another thing we can look at is if I write 5, if I write the root of 5 to the 1/2 squared, you can also see how these two cancel out based on the exponent law. Because the exponent law says multiply those two powers. What's 1/2 times 2? That's 1 whole. So you can see the inverse function of a function destroying each other in another way now, using the exponent laws. So even though it's not a supremely hard question, the hardest part was realizing that you had to draw a triangle on the edge, okay? But there's a lot of math going on in here that we can discuss that covers a lot of different topics. Okay, that is it for today. So I'm going to say bye for the recording.